Hello everyone. We will continue chapter 13, lesson 2, page 460. In this chapter, we'll discuss the following terms: solvent, solute, polar molecule, concentration, solubility, saturated solution, and unsaturated solution. First, let's remember together the parts of a solution. We know that a solution mainly is made up of a solvent and a solute. So a solution is made up of a solvent and a solute. Mainly, the solvent is the substance that exists in the greatest quantity in a solution, while other substances in a solution are called the solutes. So we have the solvent that exists in the greatest quantity, while the one that are dissolved, or the substances that are dissolved in this solvent, we call them the solutes. Second, we will discuss together types of solutions. Solutions can exist in three states of matter. Can be a solid solution, a liquid solution, or a gas solution. The state of the solvent, because it exists in the greatest quantity, determines the state of the solution. So if you want to know the state of the solution, you look at the state of the solvent. If you find that the solvent is a solid, then the solution is called a solid solution. While if it is a liquid, then it's a liquid solution. And if the solvent is a gas, then it's a gas solution. To make this clear, we can use this table. In this table, we can see the types of solution, three different types of solution. First, we have here the solid solution. Of course, if the solution is a solid, then the solvent should be also solid. In a solid solution, the solute can be either a gas or solid. Of course, if it's a solid, also we call it alloy. Okay, so we call it alloy. Alloys mainly are solid solutions. For example, if we take into consideration the musical instrument, the saxophone, it's a solid solution because it's made up of a solid copper and solid zinc. So solid solution, mainly the solvent and the solute are solids. The second type of a solution is a liquid solution. So the solvent should be or must be liquid. In a liquid solution, the solute can be either solid, liquid, or gas. For example, if we take soda as an example, it's a liquid solution where the liquid here is water, and we can dissolve in it a gas. For example, gaseous carbon dioxide, and a solid also, which is sugar and other flavors, of course. So in a liquid solution, the solvent is liquid, and the solute can be either solid like sugar, or liquid, or gas like carbon dioxide. The third type of solutions is a gas solution. Of course, the solvent should be a gas. One of the examples, the lighted sign which contains gaseous mixture of gaseous argon and gaseous mercury. You know, the lighted signs used in the roads. They are made up of gaseous argon and mercury, and both the solvent and the solute here are gases. So then this is a gas solution. So in this table, there is a summary of the three types of solutions: the solid, the liquid, and gas solution. Let's look here at water when it's used as a solvent. We know that the water can exist in three states. It can be a solid, a liquid, or a gas. It can be a solid, for example, when it's ice, when we have ice, this in this case, water is in the solid state, while when you have it as a tap water or drinking water, it's liquid. And when it exists as a water vapor, the clouds, for example, this is a gas. So we have, again, water can exist or exists in three states of matter: solid, liquid, or gas. Now, in nature, mainly, water almost exists as a solution because it contains dissolved solutes in it. As we said before, drinking water or tap water is a mixture, mainly because we have minerals dissolved inside it, so it is considered as a solution. Uh, Also, we know that water molecule is a covalent compound. Why? Because water is made up of H2 hydrogen atoms and one oxygen atom. So it's H2O. And we know that hydrogen and oxygen, both of them are nonmetals, so they form a covalent compound. Also, as we explained before, that water is a polar molecule. So water is polar, and a polar molecule with a slightly negative end and a slightly positive end, as you can see here. So it has a slightly negative end and a slightly positive end. The electrons spend more time near the oxygen atom. This makes this end, with the oxygen atom slightly negative, while the end with hydrogen atoms here, as you can see, is slightly positive. So you should know here that water is a polar molecule with two ends. One is negative, which is near the oxygen, and the other, beside hydrogen, is a positive end. Now, a non-polar molecule have an even distribution of charge. So in a non-polar molecule, we have even distribution of charge, while in a polar molecule charges are unevenly distributed. Coming back to the rule that says like dissolves like. Like dissolves like, as we said before, the polar solvent here. So a polar solvent dissolves a polar solute. So they are like. While the non-polar, as you can see here, solvent dissolves a non-polar solute. So this is what we mean by like dissolves like. So a polar solvent dissolves a polar solute, while a non-polar solvent dissolves a non-polar solute. Mainly, water, guys, is called a universal solvent. So please pay attention to this. It's called a universal solvent. Why? Because it dissolves many different substances. So we call it universal solvent. Also, water is a polar solvent. Pay attention and keep in mind that water is a polar solvent. It dissolves most polar solutes. So it dissolves polar solutes in addition to ionic solutes. So both polar and ionic solutes. How? Let's look here. For example, if we have rubbing alcohol, this is rubbing alcohol, dissolves in a polar solvent such as water. Okay, how this happens? If we look here, this is water. Okay, you know that water has a negative end here and the positive end beside hydrogen. So if we have here a negative end, then this negative end is attracted to the positive one in alcohol. Okay, maybe here like this. While the positive end of water is attracted to the negative one. So the positive is attracted to the negative, and the negative end is attracted to the positive one in alcohol. While in an Ionic solute, when we have an ionic solutes, for example, let's take an example, NaCl. NaCl is an ionic compound. If you want to dissolve it in water, for example, NaCl is made up of two ions, positive one, which is Na, and the negative one, which is Cl. If we look here, guys, let's say this is the positive one. This means that this is Na, okay? You see, Na is attracted to the negative part here, the negative part of water, while the negative ion, which is Cl, let's consider this is the negative one, this means that Cl is attracted to the positive end of water. So this is the positive end here of water, okay? And in this way, NaCl is dissolved in water. So the negative pole of the solvent are attracted to the positive ion, while the positive ions are attracted to the negative end of water. This is how an ionic compound is dissolved in a polar solvent like water. Concentration. Now, how can we define concentration? It's the amount of a particular solute in a given amount of solution. So it's the amount of solute in a solution. To calculate the concentration, we use this formula. So concentration, it's the mass over volume. So we divide the mass by volume, and then we get the concentration. So to calculate the concentration, you must know the mass of a solute and the volume of the solution. Let's take an example. For example, here we have 0.4 liters of soup. This is the volume of the solution, while we have here 1.6 grams of salt, and this is the mass of the solute inside this solution. So we have mass 1.6 grams and volume 0.4 liters. So to calculate the concentration, we use this method. Concentration is equal to mass divided by volume. So concentration is equal, in this example, 1.6 over 0.4. 1.6 grams, this is the unit of mass, and 0.4 liters, L, which is the unit of volume. And then we get the answer 0.4 gram per liter. So it's a gram per liter. Sometimes we use milliliter instead of liter. So this is the unit of concentration. It's a gram per liter, or it can be gram per milliliter. Okay. Coming back here, we have two terms to discuss, which is concentrated and dilute. What do you mean by concentrated and dilute? They are one way to describe how much solute is dissolved in a solution. Meaning, if you increase the quantity of the solute in a solution, so then you are concentrating it. While if you increase the amount of the solvent compared to the solute, then you are diluting it. So when we increase the solute, we are concentrating a solution, while when you are adding more solvent, then you are diluting it. So if a solution contains only liquid or gas, its concentration is stated as volume of solute in a given volume of solution. So we can say, we state that the concentration is volume of solute in a given volume of solution if the solution is a liquid or gas. Now, how to find the percent by volume? Percent by volume is calculated by dividing the volume of the solute by the volume of the solution. So when we divide the volume of solute by the volume of solution, and then we multiply the quotient. by 100, then we get the percent by volume. Now what about the term solubility? Mainly solubility is the maximum amount of a solute that can dissolve in a given amount of solvent. So the amount of a solute that dissolves in a given amount of solvent is called solubility, but this at a given temperature and pressure means we fix the temperature and pressure, because if we change temperature and pressure, solubility may change or will change. So in this case, if you take a glass of water and you start adding sugar and stirring, dissolving the sugar in it, you can still add sugar and dissolve it till a certain limit. At a certain limit, you cannot that no more sugar is or can be dissolved in this quantity of water. This means that this is the maximum amount of sugar can be dissolved in water, and this is what we call solubility. Two more terms also to discuss here: saturated and unsaturated solutions. Mainly a saturated solution, as it's defined here, it contains the maximum, pay attention, maximum amount of solute that a solution can hold at a given temperature and pressure. As I said before in the previous example, this glass of water, when you reach a limit where no more sugar can be dissolved in this quantity of water, this means that this solution now is saturated. Why? If we can still dissolve more sugar in this glass of water, this means this solution is still unsaturated. It's still unsaturated. So when we reach the maximum amount of a solute the solution can hold, then at a given temperature and pressure, of course, because if we change temperature and pressure, as we said before, solubility will change. So this solution is called saturated. Why? If you can still dissolve more and more solute in this solvent, in this solution, this means that this solution is still unsaturated. Okay. Now, how can temperature and pressure affect the solubility, or how much solute is dissolved in a solvent? Mainly, if you look here at this graph, we have too many curves here. Now we are explaining here how the solubility of certain substances varies as temperature increases. Can you see here the temperature is increasing 20, 40, 60, etc. If we took the first curve, let's say this is the blue one, KNO3. Look here at 20 degrees Celsius here, the solubility is 30 grams in 100 grams of water. Okay, while if we look here at 40 degrees Celsius, you see the solubility here is 60 grams, okay, per 100 grams of water. So, in conclusion, we can say that as the temperature increases, the solubility of KNO3 increases. Another example, let's look here at this yellow line. It's moving up. It's KCl. For example, if we look here at 40 degrees Celsius, let's take this here at 40 degrees Celsius, you do this like this here. Sorry. Okay, so when you reach this point and then you move horizontally, it's about 39 here. So at 40 degrees Celsius, 39 grams of KCl is dissolved in 100 grams of water. While if we look at, let's say, 80 degrees Celsius here, you move to here and then you horizontally, you see that it's about 50 grams per 100 grams of water. This means that also as the temperature increases, the solubility of KCl increases. Both of these are solids. Now, so we can conclude that as temperature increases, solubility of solids in a solution increases. But we still have some exceptions. For example, like here, Ce2SO43. This is also a solid, but when you look at this curve, it's moving down. This means that the solubility of this substance decreases as temperature increases, and this is an exception. Okay, so this is according to solids and liquid mainly. When temperature increases, the solubility of a solid or a liquid in a certain solution increases. Now, what about gases? I need to add one more thing here about gases. Okay, what happens as temperature increases if we have a gas? If we have a gas, as temperature increases, the opposite will happen. This means that if temperature increases, the solubility of a gas will decrease. So as temperature increases, solubility of gas decreases. Also, if you want to take pressure into consideration, now if pressure increases, the solubility of a gas will increase. So pressure affects the solubility of a gas positively, because when it increases, the solubility of a gas increases, while temperature, when we have temperature increasing in temperature, the solubility of a gas decreases. Finally, how fast a solute can dissolve. So to make a solute dissolve in a faster way, we can use different methods. Okay, mainly when you bring the particles of a solvent more near, or being more in touch with the particles of a solvent, so the solute and the solvent, as they get more in touch, they dissolve faster. The solute will dissolve faster. How to do this? First of all, we can use the first method, stirring. So when you bring a cup of tea and you add sugar, and then use the spoon and you stir the sugar. Why? Because as you stir it, the sugar will dissolve faster in the tea. The second way, we can use crushing. For example, as we did before in the lab, when we bring 2 tablets of vitamin C and we crush one of them, making it powder solid, and we keep the other one as it is, we add 1 tablet to the beaker, the first beaker, and we put the crushed tablet in a second beaker at the same time with the same quantity of water, which is the solvent here, and then we notice that the beaker with the powder solid or crushed vitamin C dissolves faster. The last part here, we have temperature. Also, we did this. For example, if we bring 2 beakers, one with cold water and the other hot water, bring the same amount of water, one is cold, the other is hot. We add 2 tablets in 2 different beakers at different temperature, and we can notice that the one in the beaker that contains hot water dissolves faster than the one in cold water. So these are the 3 ways in which you can increase the rate of dissolving of the solute in a solvent.